So this is going to be the first video for Note 69. I'm going to break it up into three. The first part of the video, we're going to talk about a little bit of reviewing for functions, okay? And literally, it's just asking the question, which are functions and which are not. So remember, function, a one-to-one relationship. Every one x value can only map to one y value. Now, the reason I'm stressing that and I'm doing what I'm doing as far as highlighting things is you'll notice this x value is 8, this x value is 8, but we have a problem because this mapping, right, from 8 to -2 is different than 8 to 2. So this 8 is not 1-to-1. This 8 maps to -2, but the same 8 also maps to +2. So let's take a look at the question. Which of the following are functions? No. Part A is not a function, okay? We need that one-to-one relationship. Part B is still dealing with ordered pairs. I'm going to look at my x values. -4, 2, 7, -6. None of those repeat. So yes, part B is a function. Part C is an equation. And so what we want to do is try and throw a value in for x and see what we get back out. So let's say for giggles, we test x is equal to, I don't know, 4. I picked 4, sure, why not? So y is equal to 16. So here's the deal. I put one value in, I got one value out. In this particular problem, the original equation here is a linear equation, and linear equations of this nature, yes, that is a function. All right, sliding on down, there's another equation over here, part D. We got y squared is equal to x plus 4. Again, I'm going to throw a value in for x and see what happens. So let's say in this case, I throw in x is equal to 5. So 5 plus 4, y squared is equal to 5 plus 4 is 9. I'm going to go ahead and take a square root because that's going to help me solve for y. And y is equal, now here's where the problem comes in, right? When we put a square root into a problem, we have to include a plus minus. The square root of 9 is 3. So here's the problem. I put one value in for x, but I'm actually getting back two values for y. So as ordered pairs, this would be 5, 3 and 5, -3. So part D, is this a function? A big old no, that is not a function. Okay. Sliding over to part E, we've got x squared plus y squared is equal to 36. Again, I'm going to throw a value in for x. To keep it super simple this time, I'm just going to go ahead and use 0. All right, so 0 squared plus y squared equals 36. Obviously, 0 squared is going to disappear, so we've got y squared is equal to 36. Hey, guess what? I got to take a square root again, which also means I'm going to have another issue with a plus or a minus. So when we put in the equation, that 0, we're getting both +6 and -6, not a one-to-one relationship. So is part E a function? No. Now, again, I know we talked about this in an earlier video, talked about this in earlier notes. If you recognize y squared in your problem and you see, oh, this has a y squared in it, this has a y squared in it, those are not functions, okay? All right, moving on to our pretty little picture here. If you don't know part, what would that be? F, I guess. The letters cut off in the corner here. This V-shaped graph is an absolute value graph. And regardless of whether you know that or not, what you're going to do is test it using the vertical line test. So draw yourself a vertical line. The program I'm using, I love this because it allows me to draw that line and then to move the line. Now, as I move it, I'm only ever touching this V-shaped graph in one point at a time, right? So stop there. There's one point of intersection, one point of intersection, one point, one point, one point. So there is no place on here where that vertical line ever touches more than once. And so, yes, that is, in fact, a function. It's an absolute value function. Part G. Again, what type of graph is this? You probably don't know, but this is a square root function, in case that matters for anything. But for us, it really doesn't matter if you know what kind of function it is or not. I'm saying function. It doesn't matter if you know what kind of graph it is. Spoiler alert, it's a function. I'm going to go ahead and start moving my vertical line along here. And as I move this vertical line, again, I'm only ever intersecting the graph, right? That blue curve in 1 point. So yes, this is, like I said it earlier, it is a square root function. All right, last but not least, I think this is the last one. Yep. This is a lovely circle. All right, and we're going to draw a vertical line just like the last couple of problems. I don't think my vertical line connected, so hold on a second. Let me delete that. A little glitch in the center there. All right, there we go. So I'm going to go ahead and pick this line. Now, here's the thing with the vertical line test. You could stick it right on the edge of the circle and say, oh, look, there is just this single point of intersection. So I'm trying to grab the highlighter. There we go. That single point of intersection. And so, yeah, okay, of course, that's a function. Here's the problem. It has to be any place that you draw your vertical line, right? Not just a particular place where, oh, right here works, but right here it doesn't. And as soon as it doesn't work, you no longer have any kind of a function. So a circle like this, not a function. So no function there. All right, so that's going to be the first video here. This is simply figuring out what is or is not a function. You can already see what's coming up in the next one. It's going to be evaluating and composite functions. But if you have any questions about what makes a function, testing ordered pairs functions, ordered pairs, equations, or graphs, of course, please let me know. I look forward to any questions or concerns, and I will see you in the next one.